I'm so excited that you all are here to come and move, shake, and drop with me to learn about NativeScript and Angular 2. I'm going to go ahead and get started, even though we're just a minute early. I'll let some people trickle in, no problems from me. So I just want to encourage you to go, while I'm talking, go and visit PocketRave.me, pocketrave.me. Not a Middle Eastern website, but actually it's world music. So you can start downloading the app, start creating Pocket Raves, and I'm just going to ask very kindly. I've had incidents in the past with this demo, specifically at Angular Connect. You can see it all on YouTube. But some people drew some pretty sketchy things because with great power comes great privilege. This is a live demo, and it's connected to Firebase. So what you draw is up on that screen. So just very kindly, nice things, nice things. The code of conduct in shambles. It was just not a good scenario. So I know that my American audiences would never do that to me. I'm actually serious, and I know you will not. So anyway, so go ahead, visit Pocket Rave, and let's start creating some fun art, music. And I see that some people have already discovered the light show integration, so you can go ahead and entertain yourself while I'm speaking. So my name is Jen Looper. I'm a developer advocate at Progress, which was, they actually acquired Telerik. So maybe some people, any Telerik customers? Telerik, people know of Telerik a little bit? How about Progress? Ooh, rock on. Actually, I think I spoke to you already. Yeah, OK. My Progress customer back there. Progress is a company that's been around for 13, 20 years, something like that. Telerik a little bit less. But they went on a buying spree and bought us and Modulus and several other companies about 2 years ago. So now I work for Progress. So here we go. And you can follow me on Twitter at Jen Looper. So what am I? Who am I? What is this random person talking to you about mobile development? This is my knowledge, essentially. I've been a developer advocate for within the NativeScript team. Which is very exciting because it's a greenfielded project. I mean, how many times do we have the privilege to go and start working on a project that's completely dreamed up by your company and just greenfield and built from scratch? It's an amazing, amazing experience. I'm so privileged to have weaseled my way onto that team with the likes of TJ Van Tol and Burke Holland, my other colleagues. So while I've been working in NativeScript, I've also been learning Angular JS. So how many Angular developers here? Wow. All right, rock on, Angular. So how many started with like release candidate 4, redo, 5, 6, 7? When release candidate 7 came out, we were just like, we were just like done. But now, thank God, it's in final. Actually, it's 2.1.1. So we are ready to start rocking and rolling, literally, with Angular 2. So even though I've been concentrating on this mobile sphere for quite a while, I actually have 15 years experience in this field. I've been a web developer for quite a long time. But I really started to fall in love with mobile apps as soon as I got my first little iPhone 4. It literally looks like a Twix bar at this point when you hold it. Now I have a 6 Plus. This is a big phone. So that's very stylish. So I've been building web, I've been building for mobile, I've been making a lot of mobile apps, and I just want to talk today about this cross-platform story. When I say cross-platform, I don't just mean mobile apps and web apps, but also native mobile apps that are built for iOS and Android and the web. So we're going to talk a little bit today about code sharing between web and between your native mobile app, and how NativeScript and Angular 2 will get you there. So let's just talk about this division between building for web and building for mobile, specifically native mobile. So why would you even build a native mobile app at all? Why wouldn't you just build that web app? Just have a nice mobile website, totally legitimate use case. Well, we have a lot of usage data at this point, and it tells us that web and native have their own advantages. Native is known for providing really rich and performant experiences, and the data tells us that people spend actually a lot more time within a native app on their phones. And I think actually this data is a little bit skewed by the Facebook app. So because of that app, people are literally just like sitting on their phones and interfacing with the app. But the web is known for its reach, right? The web isn't restricted by device type or operating systems. Actually, the web runs everywhere. And it's a great way, actually, to reach large and diverse sets of users, all kinds of users. So Luke Wroblewski has a quote that's quite interesting, actually, and it's true, that the web is for audience reach And native apps are for rich experiences, right? Both are strategic and both are valuable. So when it comes to mobile, it's not web versus native, it's actually both. So let's talk about how we can leverage these new technologies at our fingertips to build for both the web and for native mobile in the most efficient and painless way possible. And I use the word painless with care, acknowledging that this is really hard stuff, right? We have to deal with multiple code bases. We have to deal with fragmented platforms. I'm looking at you, Android. We have to deal with multiple language choices, Java, Swift, Objective-C, all this good stuff. And also, then you have to pick an IDE. Good Lord, there are so many choices out there, and they're all awesome. And then you have to keep your features in sync, and this is probably the trickiest bit of all. So I love my job because I get to create memes. And one of the memes that I created is, oh my God, NativeScript, and you have all these phones. So this is where NativeScript comes in to help you. So enter NativeScript with Angular 2, and it gives you this whole new cross-platform world open and ready for you. So let's talk a little bit about NativeScript for native mobile apps and what it brings to the table. Who's developing with NativeScript right now? Show of hands, NativeScript developers? Ooh, I'm glad I have all these intro slides. Okay. All right. Well, welcome to the party. NativeScript is it's a framework, it's a runtime, and it's an awesome community. So if you ever have a chance, join our Slack community. I just counted, and we're at 2,300 awesome developers in that Slack chat room. It is like a madhouse. So what is NativeScript? NativeScript is a runtime for building and running native iOS, Android, and soon Windows Universal apps with a single JavaScript code base with or without using AngularJS, okay? So why would you go ahead and start building with NativeScript? Well, several reasons. So in NativeScript, there is no DOM. We don't rely on the browser to serve up a mobile-ish web page. Our elements are actually native mobile elements. So this is very important to differentiate between us, PhoneGap, and Ionic. These are your hybrid solutions. We are a native solution. Unlike Xamarin, which is another great option for your building, we don't have this cross-compiler. So with a Xamarin app, you're going to need to compile many times during your experience. So it does, from what I've heard, I'm not a Xamarin developer, but I hear it's a tiny bit slower as you are working through your workflow. We are probably most comparable to this guy right here, React Native. But the difference is that we do offer direct access to native APIs in JavaScript, whereas React Native and Appcelerator Titanium, they have a bridge. So you're a little bit shielded from the APIs. The fact that we do allow direct access to the native APIs means that we do offer zero-day support for new features that come down the pike. So again, why NativeScript? It allows skills reuse. Sorry, this is small, you guys back there, so I'll just read it out. It offers skills reuse. You've got JavaScript developers, you've got CSS developers, people who are building in Angular 2. Come on in, and you're welcome. We do offer code reuse. You can import NPM modules, third-party iOS and Android libraries. You can grab a CocoaPod, pop it in. If you want to use a CocoaPod and something from Android, I can't remember the name of this big library, Android, it's not Studio. It's like a playground for all the Android modules. You can go ahead and create a plugin, and those are easy to write too. We have a whole room in our Slack chat on plugins, so lots of great plugin developers. You can easily use native APIs. Like I said, we give you direct access. We don't have wrappers to access native APIs like React Native does. We allow you to use native UI elements. It's open source. That's convenient considering the conference name, right? The focus here. And it's supported in Telerik platform, which I'll talk about in a minute. So let's just talk a little bit about how NativeScript allows you to make the bridge between JavaScript and all these cross-platform goodness that iOS, Android, and Windows Universal allows. Let's talk a little bit about how this works, because it is a little bit magical and it is a little bit kind of hard to understand. But NativeScript is not just a set of libraries, it's rather a runtime, and that's the key word I want you to remember, runtime, that enables you to call native APIs for Android, iOS, and Windows Universal. I think of it as like a translating engine. I say, draw me a button, And it relies on the JavaScript engine to draw a native iOS and a native Android button. It uses a prepackaged JavaScript virtual machine to bridge between JavaScript code and native APIs. And to be precise, for Android, it's Google's V8 JavaScript engine, and for iOS and Windows Phone, it's WebKit's JavaScript core. So here's some examples which run native code on the appropriate virtual machine for the appropriate platform. A little bit of sample code for you. So at the top, we have some JavaScript code that instantiates a Java Android.text.format.time object, calls its set method, and then logs the return value of its format method, which is the string 010115. The JavaScript code at the bottom here instantiates an Objective-C UI alert class. It sets its message property, and then it calls its add button with title and show methods. And when you run a NativeScript iOS app with this code, you'll see a native alert. But literally no one wants to write that code. Nobody wants to write the code. That negates the entire use case I've just presented to you, right? So let's talk a little bit about how we give you some helpers to help you avoid writing that mess that I just showed you. What you're going to do is you're going to use NativeScript modules to shield yourself with the magic bracelets from all the native code that you really just don't want to write, even if it's JavaScript. So what are NativeScript modules? NativeScript comes equipped with modules that provide cross-platform functionality, and there are lots of them, dozens of them. They're easy to write yourself if you want to. And NativeScript modules follow node modules conventions, which is the common JS convention, like this. So here's an example of a NativeScript file module. So you have one module, and two native code snippets are encapsulated. So here, this is the file system module. All you have to do is require that in and pass it a path where you want the file to go. And in the background, what's happening is that it's calling this Android code, new Java IO file, send in the path, or, I'm going to move my rubber band here, NS file manager default manager, and then file manager, I love Objective-C, create file at path contents attributes, send it the path. Okay? So with 2 lines, we avoided writing all that native code. So that's convenient. So here is what a vanilla NativeScript app consists of, with some modules like page and label here. You would have a sort of code behind file, which looks a bit like that. We have an observable module, and then you have a exports load function. And then you would style it with CSS. So you could write, a NativeScript app with just these 3 files. Presentation tier, code behind file for your business logic, styled with CSS. And you put it all together. You can magic. Very nice. Once is enough on those. So there are a couple ways to use NativeScript. You can use it with Telerik Platform, which is one of our products. So I heard some people talking about chasm techniques. One of the things that chasm training teaches you is that you might have a core product, but then all around it you have your whole product, which is basically how you monetize your open source project. So we have NativeScript open source, and then we have all these whole product offerings around it that you can use. One of them is Telerik Platform. If you don't want to deal with that and you just want to use work from the command line, you would just npm install globally NativeScript and start using commands off the command line. So the command line interface would be something like this. You'd use a command prompt on Windows or terminal on Mac. It is free. It's part of the open source project. It does require installation, and the biggest pain point I always find with NativeScript is getting the thing installed. Once it's installed, you're money ahead. You do need to get your local environment set up to build for iOS and Android. You're going to require a Mac for iOS. It does integrate with Visual Studio Code, another lovely open source project by Microsoft. Love Microsoft. Via a plugin. You might want to use this because you want more control. It's free. It integrates with existing IDEs. The people who might want to use it would be the more technical developers used to the CLI and open source developers. If you don't want to do that, you might want to use Telerik Platform, which has a nice interface on the web. It also has a plugin for the CLI called App Builder. We also have a product which used to be called Screen Builder, and I believe it's called View now, but it's a drag and drop interface, so you can create your NativeScript apps, dragging and dropping and going that way. It does require a subscription. This is a paid product, but it allows you to build in the cloud, so you don't have to do that local install. It is the easiest way to get started and offers full support for NativeScript. You might want to tune into our webinar on November 15th. I'm going to be doing it, talking about Angular support using Platform for NativeScript. Platform offers rich tooling, easier setup, integrated with the platform. Less technical developers might want this, people who prefer working in a platform, and Windows developers who are targeting iOS. So, at Progress, we build tools to help, like the Visual Studio integration for NativeScript. If you are using Visual Studio, it's now with more Angular. We have, it's hard to see, but there's a lot of IntelliSense going on here. It's very nice. And like I was saying, there's two ways to write NativeScript. You can write, what we call vanilla NativeScript, which is standard JavaScript, CSS, XML on the front end. Or you can use Angular 2. So let's take a look at how Angular 2 helps you build Angular native mobile apps. So what's the deal with Angular 2? I need a Seinfeld meme here. What's the deal with Angular 2, and why use it with NativeScript? So for the past year, we've been working to bring Angular 2 and NativeScript together. And we're doing this to provide the same experience of building mobile apps as for web apps, and allowing Angular developers to reuse their skills, like I said. It's all about skills reuse and code reuse. So what we're doing is we're taking our Angular 2 code base, mixing it well with NativeScript, and we get something like this, which we're not sure what to call it. Nangular, something like that. Angular for NativeScript, Angular native, something like that. I have the sticker to prove it. So it's a thing, because I have the sticker. All right, so why is Angular 2 so attractive to us? Well, for the first thing, Angular 1 is a technology that relies on browser tech to manipulate the DOM. Remember, it has jQuery Lite embedded in there. And NativeScript has no DOM to manipulate. So we really can't use Angular 1 with NativeScript. But Angular 2 actually decoupled the Angular framework from the DOM. And the door is now open to a new mobile-friendly tech to leverage this newly decoupled framework. And Google at this point is not even calling it so much a framework anymore. It's really a platform, because this decoupling just opened up the whole world. You can start developing for Electron, for NativeScript. Ionic folks are jumping on board. People are just like glomming on. I think I just saw Fuse Tools just started an Angular 2 integration. It's really opening up the world. It's pretty exciting. So just to give you a point of comparison, a standard NativeScript app snippet, vanilla NativeScript, would be like this. Have a little XML, and you have your code behind file and main. So here's your modules, page, page. Stack layout is our basic layout. In that, you put a button with a tap, and you're going to pop that show alert function right there, export show alert. And what happens when you tap? You get a native dialog coming up. Now, the same functionality in Angular, and I'm sorry this is small, so I'll just read it out for you. You need to put your XML within the template in the component. But before that, you need to import that component, Angular style, from Angular core. And then you need to import a NativeScript module, your dialogues module. And then you can go ahead and have your show alert tap function down here, right within the component. So it could really be done from one file. So just a different way of doing things. Same result. I know because I tested. So bottom line here, we've got a new way of building for web, building for Android, and building for iOS using shared code. So this is the idea that we can write something once and run it everywhere. And I know this is trigger language for a lot of you Java folks, but it's OK, because now we have Angular 2, and you really can reuse the code that you already wrote for the web, leverage NativeScript to build for Android and iOS to create this truly native mobile app with no web view, beautiful, buttery, smooth performance. That's the money proposition. Now to do this, we need a secret weapon. I'm going to tell you what that secret weapon is. Laser cats. There's a community initiative right now that's being built to make this happen, to build your web and your mobile apps like side by side as you go, actually with desktop as well, with shared code at the same time. And that is called the Angular 2 Advanced Seed. This was done by our wonderful community member and one of my developer experts, Nathan Walker. Big fan of his. He's really, at this point, my mentor because he's literally the only person in the whole world who really understands Angular 2, and it's really helpful to have him on our side. So very, very helpful for him to have forked Minko Deshev, another great guy. Minko wrote the Angular seed, so if you just want to build for the web, use Minko's seed. If you want to build for desktop, iOS, Android, and web, Nathan's got you covered. And here he's showing this is your website, this is your Android, and this is your iOS. All different emulators working at the same time using shared code. All right. So let's create something cool, because that's how we roll. Let's create a portable dance party with this technique of sharing code. So I decided to create something called Pocket Rave. Apparently I'm the queen of naming things. So Pocket Rave it is. And here's the icon, and here's the website. So again, visit pocketrave.me, take a look at where we're at. So the use case on mobile, this is how it's going to work. On mobile, all you can really do is view the raves that were created, because they're tiny little bits that are pulled out of Firebase. Okay? The mobile is really for creating the actual raves. And what a rave is, in my opinion, is a drawing paired with a musical track out of SoundCloud. So that's basically how we've got this thing working. And then on the web, you display it in a kaleidoscope format, which I showed as you were walking in. So I'm going to go ahead and demo this. Okay. All right, I'm going to open up Pocket Rave. So I'm in Raleigh, right, today? Sometimes I wake up in a hotel room and I just don't know. I can't remember. Oh, those are nice. All right, who wrote React? Smarty pants. Okay, well, I've seen worse. Okay, so we're going to go ahead and create a new Pocket Rave. And since we're in Raleigh, so apparently the most famous rapper you've got is, wait a second. Well, J. Cole. But before him, P.D. Pablo. Yes? Yes. I was like, I had a total brain fart right there. All right, I actually like one of his songs, so I'm gonna create this. Okay, so I'm gonna pick a color. This is a plugin, and we're gonna create some spirals. I'm gonna create another color. Oh, pink. Oh, another one. Only like orange. All right. Save it. Now this is saving up to Firebase. Now I'm going to search for PD Pablo. Yes, there it is. We need Freak a Leak. All right, so I'm going to go ahead and attach this to the drawing I just created. And now you can see it appears right here in Firebase immediately. Very nice. Let's see how it turned out on the web. Excuse me. Very good. All right. Well, it's not too bad.
Let's take some calls from the request line. Shout out to the radio station that gave you what you wanted.
I like it. It's pretty good, right? All right. That's awesome. I have horrible taste in music, so you're going to have to just deal with me. I also have 2 daughters who are teenagers, and they tell me all about what's latest in trap music, so this is very good. All right. All right, back to business. So that's Pocket Rave. You've got your web and your mobile integration. I didn't demo it, but it works very nicely on Android as well. But you can test it live and take a look at how it works for you. Play your raves with music, and there's also on the website you can control the light show. I can tell that somebody's doing light shows. Okay, so let's talk about the making of Pocket Rave. The tools that I needed to use the SoundCloud API because it doesn't require authentication, so it's actually really helpful. Mobile plugins, drawing pad, audio, play pause button, font icons, and the Firebase plugin. The Firebase plugin is one of our most awesome plugins by the awesome Eddie Verbruggen. We call him Eddie Verplugin because that's what he does. Drawing pad, funny story. We actually created the drawing pad plugin for a financial services app so people could sign their documents, and then I totally perverted it for this demo because that's much more fun. The CSS animation I borrowed from this nice code pen by Katrina Bell. And then I used the advanced Angular seed, which is our secret weapon. I used Firebase for data and image storage and hosting. PocketRave.me is actually hosted on Firebase. They have great web hosting, too. It's really fantastic. And then I have this hardware integration. That's a particle photon. It looks like it's stuck. Somebody fix it. Anyway, but it's hooked to my phone, actually, so it's getting your API calls and changing the color. So there are 4 concepts I just want you to take away on building with the advanced seed. When you download the advanced seed, it's really complicated. It's really, there's just a lot there. I actually created a really stripped down version of it, and if you visit my GitHub at JLooper, you'll find the basic seed, which actually will get you started a little bit quicker. But what I want you to understand is how you manipulate the folder structure, the naming conventions, and the code to fork the front end. And the secret behind forking the front end is actually the use of Angular 2 opaque tokens. So I'm going to explain how this all works. So first, I want to just talk about the folder structure of the code base. What happens is there's actually a symlink between NativeScript app and source client app, so that when you're making changes in your frameworks folder, you can develop in either place, and the code is reflected, so that when you need to deploy your app to the app stores, you just go into your NativeScript folder, the code's reflected there, and you can just build and deploy for iOS or Android. And so that's very, very convenient. And here's actually a better image of it. You can see the little icons here. The symlink is here. This is NativeScript app, and that's reflected downstream in source. Assets here is also a symlink, so you can share images and any image resources or audio or whatever that you want to have available to both. So that's concept 1, the symlink. Concept 2, naming conventions. So this seed is set up so that you can differentiate your web and your mobile presence. So what we have here is I only have the about. It's not available, actually. There's no about on the mobile app. But there is on the web. So all I needed to do is to create about component HTML and about component CSS, and that's it. Now on mobile, I have the ability actually to create the Pocket Raves is actually on mobile only. But I still need to have a create component HTML file. But I also need a create component.tns.html. So TNS is Telerik NativeScript. So whenever you have a TNS naming convention here, that's telling you, oh, that's going to be used on the mobile app. So that's kind of a clever little thing that allows you to really differentiate what you're doing. And the build process is smart enough to know, which is for web and which is for mobile. It's just picked up. If you need a home page that's completely different, like what I do on both platforms, here I have home component HTML, home component TNS HTML. I also fork the CSS, so I have home component TNS CSS for the mobile, and home component CSS for web. So that's just really, really great that you can, the home page is completely different. I have just a list, of the raves on mobile, but I have the whole download links on the web. So it's just a completely different experience, but you can, put your home page where you think your home page ought to be, and just fork it according to your naming conventions. That's really helpful. Okay, concept number 3. Forking the front end for the web. Here's where it gets interesting. So the seed does allow you to share a lot of code in the code behind the routes and the service files, but the front end is always going to be just a little bit different between web and native mobile, because on the web we use HTML. We can't use that on our mobile app. We have to use XML, some kind of XML markup, which is actually kind of cool, and it's not that bad to write. But here, HTML for the web is really semantic markup. It's just header with some divs, H1s, Ps, ULs, the standard HTML markup for web. And then your XML in your other file for home component TNS HTML. Here we have some nice NativeScript modules. We have our action bar module with some buttons in there. And then we have a stack layout with a button. And then the wrap layout is what allows you to lay out those cards on the home page. So we have a wrap layout here. Stack layout here at 40%. That's nested inside the wrap layout. So, so that when you tilt your phone, oh, I actually locked my phone, but anyway, if you tilt it sideways, you'll get 40% cards. So that's very helpful. All right. So once you get away from the front-end files, actually, the code sharing can begin. And as you noticed in the folder structure, you only have one TypeScript file that's controlling the experience. So we have home component TS. And that's covering all your needs for mobile and for web. That's your home page. And what's going on here is that you're initializing Firebase and setting up your base component as a home component, injecting your bits and pieces here into the constructor, and then initializing an ng on init, grabbing this raves from Firebase. That's getting all the raves that have been created, unfiltered. All right. But there's some weird stuff going on here. I'm sure you noticed. What's that? Dialogues frame from tokens. Inject dialogues as private dialogues. And then here's a weird conditional. If config is mobile native, if this frame topmost is iOS, I'm sure you can't read this, so I'm just going to read it out. This frame topmost, and then we have a visible view controller, navigation item, sets, hide, back button, animated true. What that's doing, yay, iOS. What that's doing is allowing my action bar on my home page to not have that awful back button that you totally don't want to see on a home page because there's literally nowhere to go. So that's what's going on. But how is it that we can have this stuff in one TypeScript file and it's not screwing up the web? Well, I'll tell you. So the secret weapon, special sauce, I'm totally mixing metaphors here, but it's opaque tokens. So what you need to do is you need to use the concept of opaque tokens to protect your platforms. You need to shield the web from the weird native stuff, and you need to shield your mobile app from any strange HTML. So you saw in the back, in the slide previous, that I needed that frame module to be used on the mobile app so that I can make certain things happen on iOS to the action bar there. If I imported that directly into my TypeScript file, that code would be attempting to run on a website, and it would just fail. So we're going to leverage Angular's concept of the opaque token. So this is a little bit technical, so I'm just going to make sure I get it right here. So in Angular 2, you can either use string or type tokens to make dependencies available to the injector. However, when using string tokens, there is a possibility of running into naming collisions, as the same name might exist for a different provider, especially when using third-party libraries. And opaque tokens are what are solving this problem. So standard tokens are often just simple string primitives, but opaque tokens are different because they're actual object instances. So using opaque tokens allows us to create string-based tokens without running into these naming collisions. And they're used, in a standard Angular app to allow developers to protect their code from name collisions, but we're using this in our code shared environment, actually, to stop the web and mobile platforms from colliding, because certain libraries wouldn't be supported on one versus the other. So that's kind of really, really convenient, and we're just making use of the tools that Angular's giving us. So there's a couple steps involved in creating tokens. You have a file called tokens, logically enough, in your core folder, and you just list out all the tokens that you're going to need on web and mobile and store them in a tokens shared constant. So here I need Firebase, I need my file system module because I'm creating files and posting them to Firebase. I need an image source so I can display images, dialogues, app settings. I need a loader, that little loader when it was saving, that's only on mobile. Color picker, all these weird plugins that I'm using on mobile, I need to put those in a token. And then I create two separate files. One is called tokens web TypeScript, and the other is tokens native TypeScript. You see where this is going, right? You list out the tokens that need to be available for web versus those that need to be available for mobile. So here, we're using Firebase for its web implementation, whereas on mobile, we use the Firebase plugin. And we hide these two tokens from each other by adding them to the separate arrays called tokens web and tokens native. Okay. So we use web tokens in the web module, and we use native tokens in the native module. So because each platform has its own standard Angular 2 module. So we use the tokens that are appropriate according to the appropriate module. So basic idea, use the token that makes sense for the platform by importing them when creating your ng module. And then you use them in your front-end file. So like we just saw, I need a native dialog and a native way to handle the iOS back button on the home screen. So I use an extra little protection here that's if config is mobile native, so I make absolutely sure I'm on a mobile device. And then if this frame topmost is iOS, so I even shield this bit of code from Android because it's just not legitimate. It's not a problem on Android. So there we go. That is how you go about using tokens. The seed code that I have on my GitHub has some tokens kind of scaffolded out because eventually you're going to need, you're going to need to use plugins when you're building your native script app, and so that's kind of ready for you to try. So that is what I wanted to discuss, and I just want to, encourage you to go and, grab this code. I have a little bit.ly somewhere, actually. Well, I guess I didn't list it. Anyway, go to my GitHub, grab the basic seed, and just start building and see what you can build. And I just want to thank Nathan Walker. Did this get stuck? Somebody try to fix it. Do you want me to play some pocket waves that you've created? Yes. Okay. All right. Wow. This should be a good one, nice and colorful. I like this one. This is good. I'm just going to try to fix the light show while I'm at it. Sorry, I shouldn't have stopped that, but oh, the light show is jammed. Well, we'll sort it out. Oh, I think maybe I lost connection to my phone. That's probably what happened. Anyway, thank you for coming. If you have any questions, we have time. Any questions? Questions? Everybody runs. She's like, she's crazy, get out of here.